I'm building the world's first Raspberry Pi gaming PC, and powering it, this tiny Compute Module 4. This isn't a normal Pi though, it's like an APU with the processor, networking, and GPU all built in. So to run it, I'm going to need a motherboard. And the motherboard I'm going to use is not this one, it's actually this one, Axzez's new Interceptor. You didn't think you could plug a Raspberry Pi into one of these motherboards, did you? You know what else you didn't expect? This video's sponsor, Micro Center. If you've never been to a Micro Center, you're missing out. I mean, sure, you got all the boring PC build stuff that you'll find on LTT or PC Master Race, but did you know they also have a whole aisle of 3D printer filament? I mean, look at this. There's even transparent pink filament I can use to print a unicorn for each of my daughters. Not only that, but look over here. This whole section is devoted to makers with Raspberry Pis, Arduinos, and even soldering gear. And my kids could watch the 3D printers all day. Heck, there's even an Apple section with Macs, iPads, and iPhones. Check out Micro Center in a city near you and check out the end of this video for a special offer. While I was at Micro Center, I also picked up this Asus GT501 case and an MSI G241 gaming monitor. Those may seem like overkill, and well, they might be, but I'll be pushing this Pi to the max, overclocking it to get 120 Hz on the Pi's integrated video core GPU. Because of that, I'll also need some active cooling. Since I blew the budget on this case and monitor, I can afford to downsize a bit on the CPU cooler. This one should work. I also grabbed a new keyboard and mouse. The official ones from Raspberry Pi don't have any RGB, but they do look nice in black. To round out this build, I'm going to take advantage of the Interceptor's 5 SATA ports to install 4 4TB NAS hard drives I already had, along with this insane 8TB SSD for a boot drive. I mean, with the size of PC games this day, that 24 terabytes of space might not even last that long. With Mirrored RAID, I could only store 50 games the size of Call of Duty Modern Warfare. In a SATA boot drive, I hear you ask? You can't do that on a Pi. You even said that in last week's video. Well, you're right. The Pi's firmware technically doesn't allow SATA boot. It only works with microSD, USB, eMMC, or NVMe. But Axzez can install their operating system on a SATA drive with one caveat. On light compute modules, you have to keep a USB flash drive plugged in at all times. Speaking of USB, the Interceptor has 4 USB 2.0 ports, 2 here on the rear and 2 from this header. I have this little adapter that lets me plug in the case's front panel ports, though it's a little downgrade from the USB 3.0 this case was built for. Outside SATA and USB, the Interceptor has all the basic features of a standard mini ITX motherboard, like a 24-pin ATX power supply header and front panel connectors. And Axzez actually sells this ITX adapter plate. And when I asked,
does it come in black?
They said no, so I did my own little operation. So let's put it together. Now, a lot of problems that people have with Raspberry Pis are because of inadequate power supplies. That won't be a problem here. I'm using this Corsair 650 watt power supply. I actually don't need 650 watts for this build, but it is important to make sure whatever power supply you use, it does 2 things. First, it needs a stable 3.3 volt rail, which many cheaper supplies don't. And second, it should be designed so it can handle lower loads like this Pi board without tripping an undervoltage protection circuit. Axzez maintains a list of tested compatible power supplies on their website, and in terms of power, I only really need a 24-pin motherboard connector, SATA power for the hard drives and SSD, and 1 more SATA connection for RGB. Alright. That. The Interceptor has a bunch of 3-pin fan headers on it, so I can plug in the exhaust and intake fans, but there's no PWM control, so even PWM fans like the one that came with this case would still run full blast here. Oh, I think that's already stripped. Don't drop this. Now it's time to get the Interceptor mounted. First, I'm going to pop in this 3D printed I/O shield, which I designed in OpenSCAD and put up on Thingiverse. Then I'll prep the motherboard on the adapter plate. It's always a good idea to install your CPU cooler before you put the motherboard in the case, so I'm going to stick this little cooler on the top. Since the Pi system on a chip only has a 4-watt TDP, it's not like you need a monster cooler like you would on a desktop CPU, except I just realized that there's not a 5-volt header for me to plug this fan into, so I'm going to take a quick break and figure something out. Alright, so I asked Axzez about it, and they said that I could leech 5 volts off a SATA power header on the power supply, but I actually had a better idea. Dixon Chow recently started selling this new heatsink kit for the Compute Module 4, and he sent me one to test. Also, shout out to Gamers Nexus for this nice mod mat. Highly recommended. Alright. That heatsink was actually slightly more complicated than I thought it would be. Alright, and with that, it's time to pop this board in the case. Now, I'm going to need some screws to put these in the standoffs, so I need to get that out of the case. Actually, I'm going to move this case over to the other side. Okay. So this has all my motherboard screws. And I might go back over here. This is the first time I've ever done a build with a thing this big, so I'm going to switch it back over to the other side so I could get a better angle so you can actually see what I'm doing inside. Okay. Alright. First, I'm going to plug the case's front USB 3 ports into the board's USB 2 header using this adapter that I found from Amazon. Then I'm going to plug in the front panel power switch and power LED connectors. This case also has an HD audio plug for the headphone out and microphone input on the front panel, but obviously this motherboard doesn't have that, so I'll just leave that hanging out. Now, while I'm back here, I'm also going to plug in the exhaust fan to one of the fan headers on the board. And I'll go ahead and plug in these other front panel fans. There are 3 intake fans on this case, and I'm going to plug them in as well. Okay, so the fans and the case plugs are all in at this point. And now it's time for storage. There. Good thing the hard drive's not in. Mm-hmm. While I'm down here, I might as well install the power supply as well. Typically you'd do this before the motherboard, but in this case, on this particular build, the motherboard is pretty small, so that doesn't matter too much, the order that we do it. But you should make sure the fan, which is going to draw air in, is actually facing where the intake is on your case, and in this case it's here. Cool thing about this case is it has filters on all the intakes, and you can also configure it. If you're building a massive PC with radiators, you can configure it on the top, the front. It's a nice case for that. All right, and then I got 2 more hard drives for the back side. Which is over here. We already got a little bit of a rat's nest of cables, but we'll take care of that in a bit. These last 2 hard drives come in over here. And one thing I don't really like about this case is the fact that there's no ventilation on this side at all. Yeah, there's no way for the air to get through on this side. So these hard drives will be sitting back here. The only air they're going to get is coming through these little holes, and not much. So that is one downside to this case, and that's one thing. I know that there's other cases that are more catered towards hard drives. This is not one of those cases.
Don't tell Danny this, but I'd rather be watching a movie than doing what I'm doing.
Yep.
Mom, you didn't tell Danny that, did you?
Yep. Well, you're not a camera person. Camera people like being camera people. Okay.
It's not terrible, it's just lack of movement.
Yeah. Got the hard drives in. Have our RGB controller over here. Just the one that comes with the case, not anything amazing. And I'll get all the power and SATA connections wired up. Let's come around this way. Okay. So we get motherboard. Nope, that sounded like it went in. Okay. Yeah, well, one of the two. Yeah. Hello. So I got power. Now let's get these SATA plugs. Should have 5. Go. That. Clean up the bottom with this vanity plate. I put 2 3.5-inch drives in these bottom trays and 2 more on the back side, filling up all the 3.5-inch bays in this beastly case. Then I stuck the SSD in this bottom 2.5-inch bay. This case is designed for gaming builds with giant coolers and GPUs, but unlike more storage-focused cases like the Cooler Master LAN box, I don't know if I'd recommend this case if you need to install more than 2 hard drives. I mean, look at these 2 3.5-inch bays on the back. They don't get any ventilation at all. Now, I'm going to use a little editing magic and clean up this rat's nest of cables and... Okay, now all I need to do is get this other side panel on. And then everybody's favorite part. Just have to remember to not set this thing on a tile floor. I want to keep this glass intact. For a monitor, I went with the MSI G241 gaming monitor. I found out a couple years ago the Pi struggles a bit at 4K, so I think 1080p is the sweet spot. But I did want to see if the Pi could handle more than 60 frames per second, and that's why I went with this gaming monitor. This one can hit 144 Hz, but the Pi can technically only get to 120. And this could be a waste if the Pi can't perform at 120 frames per second, but in that case, I could use the monitor for gaming on a PC I'll be building soon. Subscribe if you want to see what happens when I try building my first PC since 1999. Wait a second, there's a graphics card in there. Editor, play that back. Why can't I just use that RX 6700 XT on the Raspberry Pi? It's more than adequate. Well, I'm working on that. I have gotten further along hacking the AMD driver in the Linux kernel to work with the Pi, and CoreForge even got an older card to run some 3D graphics. I'll give an update on external GPUs on the Pi soon, but on this build I have to stick with the video core GPU inside the Pi's system on a chip. Moving on to peripherals. On my main workstation I use an Apple keyboard and Magic Trackpad because I like the feel. Yeah, I'm a bit weird, but I also don't game on my main computer. The Pi mouse isn't terrible. It's nice and light, though clicks require a bit more force than I like for gaming. And the Pi keyboard is a little spongy, but when it comes to looks, the gray on black color scheme is nice if you're okay with no RGB. Alright, moment of truth. Let's see if this thing boots. Ah, the sound of NAS hard drives coming to life, and even with all 4 of these fans running, it's still pretty quiet. And the Interceptor booted up right away when I switched on the main power supply, but I actually made sure to set a couple EEPROM options on this Compute Module 4 so it can work with the ATX power supply and power button. Speaking of EEPROM, there's no OS installed on this Compute Module even though it has built-in eMMC storage. But that's not a problem because I'm running the new firmware that has network install. I talked more about that in the video from last week, linked right up here. All I have to do is plug in a network cable and then I'll be able to install the 64-bit Pi OS. Alright. While it's installing, I should also mention Axzez maintains their own OS image. You just flash it to a USB drive and plug that in before you boot up. Their image includes ZFS and all the drivers to configure the onboard Ethernet switch. That's this chip here. And with that, you can set up a custom network using the 3 additional LAN ports that are controlled in the OS. For this video, I won't run their image though, because I don't need to test out the networking features, and I'll talk a little bit more about that later. Choose storage, we'll choose the internal SD card reader. This is actually the eMMC built into the Pi. All right. And actually, I'll peel this off. There we go. Okay. It looks like the install is finished and it's rebooted a couple times, so now it's time to see if I can get this thing to game. First, I'm going to try to set the display to 120 Hertz. After doing a bunch of research, it looks like the best way to do that is to put these custom HDMI settings into the Pi's boot config and restart. But after I rebooted, I opened up the UFO Motion test site and I'm still only seeing 60 Hertz. What's up with that? Well, using Xrandr, I can check on the refresh rate on the command line. And look at that, even though it sees the monitor can do 120 Hertz, it's still on 60. I'll force the change with this command. And after the screen updates, now UFO's looking a little better, but we're still not getting 120 Hertz. For that, we're going to need to overclock. You can actually get a Pi up to 2.2 or even 2.4 gigahertz in some cases. Heck, if you're willing to go to extremes, somebody on Twitter got over 3 gigahertz. But I've found that this Pi is stable to about 2.1 gigahertz, so that's what I'll stick with. I'll put the overclock settings in my boot config and restart the computer. And after that's done, it looks like we can get 120 Hertz on the UFO test, though only on the simplest test. If I switch over to video game motion, the Pi's little GPU can't render fast enough for a full 120 frames per second. Well, benchmarks are one thing, but how does it game? I'll be the first to admit I'm not a hardcore gamer, and I'm even less of a Raspberry Pi gamer. Channels like ETA Prime, Lee PSP Video, and MicroLinux have more content about Pi gaming and emulation in general, but the goal I have is to get more than 60 frames per second on the system, and the game I'm going to test it out on is good old Quake 3 Arena. Most of my friends were more into Unreal Tournament back in high school, but Quake 3 Arena got way more playtime on my old blue and white G3. And what's really awesome is id Software open sourced the game engine a few years back, so you can actually run it on a Raspberry Pi. And of course, instructions for all this are in a blog post on my website, just like everything else I do here. So I installed it along with the demo game from Game Data Packager, and let's see if I can break 60 FPS with all the settings on low. It is really hard to play that at an angle. Alright, so with an overclock, I'm getting more than 60 frames per second, but not quite a full 120. I should note that there's a more optimized port for Raspberry Pi called Q3 Lite, but it won't run on newer Pis. With that, maybe it would be possible to get 120 frames per second, I don't know. So playing 3D games might not be the best thing here, but I still have 24 terabytes of internal storage, so that's something, right? I mean, I could store all the massive game libraries for everyone I know, so nobody would need fast storage on their own computers. Well, yes and no. I've tested different RAID setups. I ran ZFS and traditional RAID, and I could get up to 400 megabytes per second on the Pi itself, so not the fastest in the world here, but over the network, it can only get up to about 100 megabytes per second. That's not bad for a NAS for storing videos and other files, but I wouldn't run game data straight off of it over the network. With the 3 extra LAN ports on the back, you could skip bringing a network switch to a LAN party, but I guess this isn't 2000 anymore and people probably don't do LAN parties. So what is this system good for? Well, I'm gonna be honest. The Interceptor isn't built for a gaming rig like this one. I wanted to do this build to take the Pi to extremes and see how far it can go. And with the crazy amount of cooling and thermal dissipation of that CM1 heatsink, it went pretty far. Getting more than 60 FPS isn't nothing. But if you want to play any newer games, a cheap PC with integrated graphics would still be a better bet. But what the Interceptor is built for is storage. Specifically, it's built to be an NVR, or network video recorder. The idea is you would plug IP cameras into these extra LAN ports on the back, and the Interceptor would quite literally intercept the video signals and record them to disk. Thus, the 5 SATA ports for a boatload of storage. And here's the kicker. They're building a custom 1U rack mount case for this board. The case will include a power supply, space for the Interceptor, and slots for 5 3.5-inch hard drives. perfect for a power-efficient DVR. And it looks like there are plans for some sort of expansion on the back, but I couldn't get a clear answer yet on what that'll be. Go follow Axzez on their website and hopefully they'll reveal more soon. So you can already order the Interceptor. They have another batch coming soon, and it even has a few improvements, like they moved the SATA controller chip, this little guy here, out from where it is underneath the Pi, where it is on my prototype version. The Interceptor costs 99 bucks, and the ITX adapter plate costs an extra 9. Though you won't get a special Chrome Delete edition like I made here. For that, you'll have to go buy a can of spray paint and do it yourself. So the Interceptor is great for what it is, but it hasn't yet realized my dream of building a powerful Pi gaming rig. But I am still trying to get this graphics card working on the Pi, and I'm going to be building a PC in this case next week. That'll be the first PC build for me in 23 years. So subscribe, and until next time, I'm Jeff Geerling. On light computers, not quite a full 100, with one caveat. Other people do this a lot better than I do, but that's okay. Number 2. I should have used the slate, but it's back there actually. That's what the slate's made for. Back a tiny bit actually, because now you're getting the moire.
Moire? I'm guessing that means those lines across the screen.
Yep. And I just realized the teleprompter's been going this whole time, and it's just told me to look confused, and I am confused. Using the adapter that I picked up on Amazon, which is right here. This will be edited out so it will look like magic. It's true, but it's also in the script. This video was a lot of fun to make, and I couldn't have done it without Micro Center's help. And they want to help you too. Micro Center wants to offer new customers a free 128GB USB flash drive and a 128GB micro SD card. New customers only, no purchase necessary, limited time offer, valid in store only, limit 1 coupon per customer. Now that the legal stuff's out of the way, check out the description for the link and for links to all the projects and guides I mentioned in this video.